All right, let's take a look. Find the length of chord EF and round to the nearest tenth. All right, so let's take a look at our picture again. So we have this property. We know we can see that we have a radius. We can see that it's perpendicular to a chord. What does that tell us about the chord? It tells us that that radius cuts the chord in half. The other thing we know from the picture is that the radius has a length of 40 plus 30 more, or a length of 70. Now we've done a question like this in the past, and we're going to follow the same process. What we're going to do is draw another radius, specifically from the center to one of the ends of that chord that we're trying to find the length of. So I'm going to go from C out to F, and this is specific. We have to do it that way. We have to draw it from the center to one of our ends. You could also do it to that end. Okay, notice that forms a right triangle. This side is length 40. This is the side we're trying to find this length. And this side is the radius, which we knew was 40 plus 30 more from the center to the edge. So we knew that this side was a length of 70. Okay, again, I'm just going to kind of pull that right triangle out here just so that it's easier to work with and it's not kind of caught up in that picture. Okay, so I've got it, it's going exactly the same direction. Again, we knew that this was 70, this was 40, and this part we don't know. We're going to use the Pythagorean theorem, which is what we use with right triangles. A squared plus B squared equals C squared. A and B are the legs. Those are the sides touching the right angle. So one of my legs is 40. The other leg, I don't know what it is. We'll just call it B. And my hypotenuse, C, is 70. The hypotenuse is always the one across from the right angle. Okay, let's simplify a little. So go ahead and do 40 squared. Again, when you square a number, that means the number times itself and not the number times 2. 40 times 40 is 1,600. Plus B squared equals 70 times 70, or 70 squared, is 4,900. We need to solve this, so we need to get B by itself. Right now we have a positive 1,600. If we subtract 1,600 from both sides, then we'll be at least down to just a B squared. Okay, so we'll have B squared equals 4,900 minus 1,600 is 3,300. We're not done because the B is still squared. So to solve, you do the opposite of squaring, which is to take the square root of both sides. That gets rid of my squared, and I just use a calculator to do the square root of 3,300. When I do that, I get 57.4. Okay, do I have my answer yet? Well, not really. All I've found out is that the length of this side of my right triangle is 57.4. So what I need to do is now take it back to my circle where it came from and say, okay, that means that this segment is 57.4. We knew that radius bisects the chord, so this would also have to be 57.4 because bisect means to cut in half. So my segment EF would be equal to the 57.4 plus another 57.4. And I end up with 114.8. So the length of EF is 114.8. Okay, so again, if you need to replay this and go back through the